Okay, so the next test in chapter 1, class 10 is your Test-1C. Okay, so the test question paper contains this question, 10 of them, where we have to write the equation and balance it. Okay, so one is, I'll just read it through by test 1A and B we have done in slowly and in detail. So by now I think we can write directly by reading the question. So look into your question. 1. Precipitation reaction of lead nitrate solution. So let us write here in the extreme left corner. Lead and nitrate, let us write it down. Okay, so that we have space on the right side. So lead ion is Pb2 plus, right? Imagine that here. Nitrate ion is NO3 1 minus. So this 1 and 2 valency can't cancel, so 1 goes at the back of Pb, which we need not write, and then 2 here at the top. The valency of Pb will go to the lower backside of nitrate, NO3. After a bracket, the 2 will come down, because nitrate is a compound ion, meaning it contains more than one atoms. You see here, one nitrogen atom. Nitrate ion contains one nitrogen atom and 3 oxygen atoms. So in total there is 4 atoms. So any ion containing more than one atom is a compound ion. So if it's a compound ion, then and the valency you're bringing down is greater than 1, like in this case 2, then or 3, whatever, then we must put a bracket, right? If it's a compound ion. Any ion containing only a single ion, like Na plus, only one ion, sodium atom, one atom, is called a simple ion. In such kind of simple cases of simple ions, we need not put a bracket. Okay, so lead nitrate with potassium iodide. With means you can just write here plus. Okay, so that's in solution, means it is dissolved in water. So if you want, you can add this small aq, meaning this lead nitrate is in the dissolved in water. Solution of water is called aqueous. But this, even if we forget, sometimes not so strict. Okay, the precipitation reaction of lead nitrate with potassium iodide. So a little bit below the plus, let us write the name. Potassium iodide. Now potassium and iodide down, that will save space on the right side for us to complete the equation on a single line. So because when it's in a single line, the equation is easier to balance. So here what we need to know is that potassium iodide is also in the solution form. So here K1 plus, okay, and iodide is I1 minus. So both 1 means remains like that. So by reading the sentence, we have to write the word equation, skeletal equation first. Give you, now they have given in the question, but even if they didn't give, this is double displacement. This will go, lead will go here, potassium will go here. So it's quite easy to figure it out. So the question is saying anyway, to give lead iodide precipitate. So lead iodide. So this is also solution. So you may add here AQ to give lead iodide. So let us write here lead iodide. Now lead ion is Pb2 plus, iodide ion is I1 minus. So 1 here and 2 here. So can't cancel. So this 2 at the top of Pb will go to the lower backside of I without a bracket, because I is a single atom. Iodide ion is a simple ion because it contains only one atom. Any ion containing more than one atom is a compound ion. Like iodide, containing only one atom is a simple ion. So if it's a simple ion, we should not put a bracket rather. Okay. Then this is precipitate. So precipitate PPT, precipitate means in a solid form. like this. And potassium nitrate, so potassium nitrate plus potassium nitrate. That's what it gives, the question is saying. So K1 plus nitrate is NiTrA TE, so NO3 1 minus here also 1, here also 1. So that is it. So obviously this is in the aqueous form. This is the precipitate, means it has precipitated out as a solid. Okay, solid. Now once we have written the equation in this symbolic form, it's called a skeletal equation. That means the skeletal equation has not yet been checked for balancing. That means it may not yet be balanced, so we need to balance it. Now we can balance it directly now, I think, because you are getting more comfortable with it. Start with the first atom, Pb. The bag is 1, no Pb here, 1, and no Pb there. So left side also 1 Pb atom, right side also 1 Pb atom. So it's so far balanced. Now let us go to nitrate. If you go to nitrate here, this bracket means this number 2 belongs to both N and O3 here. So you need to multiply 2 ones are 2 N is there on the left side. Let us check how many N is here. At the back 1, nothing means 1. So only 1 N is there. So you need to put here 2 to make it equal to this 2N. Then 2 ones are 2N also on the right side. So N is also balanced. Lead atom, nitrogen atom. Then let's go to O. Here 2 3s are 6 O is there on the left side. No O here, so it makes our job easier, right? O here 2 3s are right side also 6 O, so it's balanced. O is also balanced. Lead, nitrogen atom and oxygen atoms are balanced, or both from the left with the right, right on the row. So now go to the next atom, which is K. Here we see only 1 K, but on the right side we see here 2 K. So right here 2 K on the right side. So even the left side should have 2 K. So we write 2 to make it 2. So K is also balanced. One more item is there we need to balance, it is I. The bag is 1. So when a number is written right in front, that number will now belong to everything after it before the next compound starts. Okay, so 2 ones are 2 I on the left side, 2 iodine atoms. That means, and on the right side also 2 iodine atoms. So now this equation is balanced. We can read it as no number means 1 molecule of lead nitrate reacts with 2 molecules of potassium iodide to give us 1 molecule of lead iodide and 2 molecules of potassium nitrate. Okay, so let us go to the next one. Number 2. Question number 2. Let us see. Strong heating of copper in oxygen. So copper is Cu. Strong heating of this substance copper on heating in oxygen means O2. Okay, so when you do strong heating, condition of the reaction you can write above and below the arrow also. Then it gives us copper oxide. So we write here a bit below the arrow, if you want to write the name first, copper oxide. So copper ion is Cu2 plus, oxide ion is O2 minus, so 2 and 2 cancel, so the copper oxide is that one. Right, so here let us balance. On the left side 1 Cu, on the right side also 1 Cu. So far seems to be balanced. On the left side is 2 oxygen atoms, on the right side only 1, so you need to put here 2 ones are 2 to make it equal both sides, because principle of atomic conservation tells us that the number of each atoms on the left should be equal to that on the right. Okay, so 2. But once you do that, copper has become 2 on the right side. So with your pencil you can do this part. This part is not necessary, just to help us see. 2 on the rough you can do in exam if you want to do it. 2 Cu. Here also we need to put here 2 to make it equal, and so now left and right also has 2 copper atoms, so it's balanced now. You can read it as 2 copper at the back, no number means atom. 2 copper atoms react with 1 molecule of oxygen, more than 1 atom, so molecule, to give us 2 molecules, because 1 plus 1, 2 atoms, so 2 molecules of copper oxide. This reaction can be easily identified. You can take the copper wire, electric wire, which is brown in color. Copper is always brown in color, and hit it strongly in oxygen. How do you know you got copper oxide? You'll get a blackish deposit. These are just extra information, confirming that copper has been heated strongly into a new compound called copper oxide, which is blackish in color. Okay, so next, number 3. Question number 3. Heating copper 2 oxide in hydrogen. So let's write your copper 2 oxide, and let us write the formula: Cu2 plus copper 2 ion oxide, O2 minus, so 2 and 2 cancel. Copper ion and copper 2 ion are same, right? Copper ion or copper 2 ion or cupric ion is the Cu2 plus. Cu2 plus is the common one. Copper ion or copper 2 ion or cupric ion. The uncommon one is this one, Cu plus, which is copper 1 ion or cuprous ion. This is not copper ion. This is the one. Okay, this is called copper 1 ion or cuprous ion. So next here. So number 3, in hydrogen. So in hydrogen, so let us write here hydrogen, and we know that hydrogen is the gas. H2 yields hydrogen atom, hydrogen ion, hydride ion, and this is hydrogen or hydrogen gas. H2 is hydrogen or hydrogen gas. So heat, and then we get here this one. We can follow a trick. So give free copper, so box this one, and free copper means copper get detached from O and come out free, alone. Free means alone, like this. Box it, just a trick. Okay, in exam you don't need to do this. So that comes out, plus whatever outside the box will combine. So O and H2, the only way to combine these to get a correct compound is H2O. See here, no box has come out as H2O, which is simply a steam. Come out the steam, gaseous form, which we need not even write. So no need to balance even here, very easy. Cu, this H2O, the whole thing has gone this side, so it would be automatically balanced, right? So this is a trick you can follow for this. Then question number 4. Heating zinc oxide in carbon yields free zinc. Heating zinc oxide, so let us write that, zinc oxide. So Zn2 plus is zinc ion. Oxide ion is O2 minus, so 2 and 2 cancelled. In heating zinc oxide in carbon, so a little bit below there we can write carbon means coal, coke, carbon, coal, coke. All this means the same thing. It is denoted by the symbol C. This is used for burning. Okay, so when you burn zinc oxide in carbon, koila, then you're going to get, that means you're heating actually. Free zinc means zinc will get detached. The word free zinc simply means zinc is coming out alone. So box it. So whatever is box left side has changed that side to the box same one. Whatever is outside the box, try to combine it to get a correct compound. The only way to get a correct compound here is CO, which is carbon monoxide. So this is also very easy. You can just follow this trick, box it and remove the zinc. Whatever is left outside the box, form a correct compound. This is nothing but free zinc means zinc, free copper means copper, and this one is steam. Okay, so automatically it would be balanced. These two are similar tricks. Okay, so if you follow certain tricks, there are many equations that can be automatically balanced. If you remember the trick, then it makes it easier for you, right? So next, number 5. Let us see. Question number 5. Read it for us. Reaction of chlorine with hydrogen. Let's write your chlorine with hydrogen a little bit below the plus. So hydrogen we know is H2, chlorine is Cl2, right? On your worksheet 1 double plus we have studied this. This is chlorine atom, this is chlorine, this is hydrogen atom, this is hydrogen. When we say hydrogen is a hydrogen gas H2. When we say it's chlorine, it means the chlorine gas Cl2. So these two combine, or chlorine with hydrogen sulfide, sorry. Hydrogen sulfide, I'll miss out that word, sorry. Hydrogen sulfide, so this needs to be corrected. So hydrogen is H plus, hydrogen ion, sulfide ion is S2 minus. So this 2 minus will go to the lower backside of H. This hydrogen sulfide H2 is a gas, okay? It smells like rotten egg smell. Remember that objectives can come out now. Then to give you, remember this, when chlorine reacts with hydrogen sulfide, this sulfur will come out as free sulfur. S means you know sulfur. Box it up. No need to box in exam. Right now while practicing box, use the box technique. In exam you box by imagination. Even these things, it will make it easy for you. Whatever is outside the box now, you try to make it a correct compound. So H2 and Cl2, the only way to make it a correct compound is 2HCl, which is H plus is hydrogen ion, Cl minus is chloride. So hydrogen chloride gas will be formed. It's already balanced. Cl2, H2, 2 in front means 2H, 2Cl. Balanced it is following the same box technique. 3, 4, 5 we can do easily by remembering the box technique. Right, box the one which is coming out free. Here copper is coming out free, box left side, right side the Cu. Here zinc is coming out free, so box the zinc right and left. Here sulfur is coming out free, so box the sulfur on the left and the right, and whatever is outside the box in all these three cases, you think about a correct compound and write it, and it will be correct. And it will also be automatically balanced. You need not do anything to balance anymore. Okay, so that is your 5. Let's go to 6. Read. 6 is reaction between manganese 2 oxide or manganese dioxide. So manganese, manganese 4 oxide it's written, or this compound can also be called as manganese dioxide. Both are correct. So let us try the first technique. Manganese 4 ion is Mn 4 plus. No need to write this, I'm just explaining. Oxide is O2 minus, so 2 1s are 2, 2 2s are 4. So the compound will come out as this 2 will go to the lower backside of O. 1 need not be shifted, so this is MnO2. This one is also simply read as manganese dioxide. Manganese 2 at the back of O. Like that also you can write. And hydrochloric acid. So reacting with hydrochloric acid. So let's write here hydrochloric acid. Hydrochloric acid is simply this hydrogen chloride gas. If you pass in distilled water, it gets dissolved. So distilled water containing dissolved hydrogen chloride is called hydrochloric acid. So hydrochloric acid is the liquid in which is the dry hydrogen chloride gas dissolved in it, and hydrogen chloride is a pure dry gas. Hydrogen chloride is the gas, hydrochloric acid is the hydrogen chloride gas dissolved in water. So hydrochloric acid to give, question is saying to give yielding manganese chloride. It will be below the arrow on the right side. Manganese chloride. Let us write the equation or compound. Manganese ion is Mn2 plus, chloride ion is Cl1 minus 1 and 2, so 2 will go to the lower backside of Cl and no bracket because Cl is a single atom, simple ion, right? So and water and chlorine. Water though we know H2 and chlorine also we know Cl2. So chlorine gas. This is the skeletal equation. Now we need to balance it. So let us check for balancing. Here in this one, it's easy if you start balancing with Cl. Okay, so here on the right side is 2Cl. So on the right side also, left side also should be 2Cl. So for that, you need to put here 2. Ones are 2Cl, Cl2. Sorry, 4 is there. 2 plus 2, 4Cl. So you just put your 4. See, here's not 2, sorry, 4Cl. Balance the Cl first. 4 on the left, 4 on the right. Okay. So once we do that, the rest will begin to slowly balance out. Next 4H is there on the left side. I find that if we balance this Cl and H, first the rest will begin to automatically balance. As we said in the beginning, balancing chemical equation has no fixed technique. We need to do by trial and error method and adjust in certain cases. We find, okay, if I start with this, I think it's going to be easier. Like that, by adjustment we do. Don't have to worry too much. The more we practice, we get those ideas picked up. Okay, 4H. So 4H means here only one place H is there, no more. So the only way to make it is 2 2s are 4H on the right side, already 4H on the left side. So once we do that, maybe we can go to O, because 4H and H balance means this whole thing will be balanced. So O, 2 ones are 2O on the right side. Left also should be 2O, which is already so. And once we do this whole thing and O done, we'll go to Mn, the last one. Mn, 1 Mn, 1 manganese atom. That means here also 1 manganese atom. So the equation is now balanced. We'll read it as 1 molecule of manganese 4 oxide reacts with 4 molecules of hydrochloric acid to give us 1 molecule of manganese chloride, 2 molecules of water, and 1 molecule of chlorine or chlorine gas. That's the next one. Okay, and then see, I think we can complete in this class itself. So let's go to the 7th equation. The 7th equation is, by now we're getting more comfortable, so we can do directly. Rusting of iron in moist air. So we put iron nails, shiny iron nails. Iron which is not yet rusted, let us say. Let's say shiny. You know it, right? But I'm just writing for making us understand easily. Identify, learn easily, understand easily. So shiny iron nail which is new from the market, you take 1 or 2 pieces and expose it to moist air. The word moist air means it's wet, so water will be there in the atmosphere. How much water is there we don't know, so just put X. Okay, and then air means oxygen will be there, just write O2. What do we mean X is there? Usually Kohima is more dry, the air is more dry, means there's less water vapor in the air. In Dimapur it's humid, means there's more water vapor in the air, so X will be high in Dimapur. Kohima X will be low, so we don't know, different places have no fixed water vapor content, that's why X is put there to mean depending on the places. Okay, so moist air means definitely water and oxygen will be there. Of course carbon dioxide and all are also there in a mixture of air, but since carbon dioxide does not react with iron, we don't put it. So when iron is exposed to moist air, means water vapor and oxygen, over a period of 2-3 weeks you will see a reddish brown. Okay, most textbook call this reddish brown rust will develop. This brown rust. Now have you seen iron nails brown color, that is rusting. So that is nothing but, that is called hydrated ferric oxide. Okay, hydrated ferric oxide. So forget about the hydrated, let's write this one first. Ferric is Fe3 plus, oxide ion is O2 minus, so 2 will go at the back of Fe, 3 at the top of Fe will go to the lower back side of O. And put a dot and then X H2O. You write this is called a hydrated ferric oxide. The reddish brown color is this ferric oxide, the rust. The rust formula is Fe2O3. Since it's wet, XH2O hydrated means it's wet. Now to make this, on the right side there is only one substance here. On the left side there are 3 reactants, 1, 2, 3. So it's more difficult to memorize left side. So just memorize. On the right side it always contains 2 molecules of hydrated ferric oxide. This is already balanced and correct. Keep that in your mind, memorize the 2 and go in example. Then use this side, right side, to help you balance the left side. That's the technique that makes it a lot easier for you. Let's start with Fe. 2 2s are 4, right? So you put here 4. Now it's balanced. 4 Fe, 4 Fe. Next, 2 3. Don't look at this O, only this one. 2 3s are 6 O. So here also 3 bigger than this 2. 3 2s are 6 O balanced. Then here X H2O. 2 1s are 2, so put here 2. It's balanced now, right? So this is how you can balance. So when shiny iron nail is exposed to moist air, means containing water vapor in the air and air, this air and water vapor will react with iron to cause the hydrated ferric oxide brownish rust, whose formula is Fe2O3 dot XH2 hydrated ferric oxide. Rust, that brown color rust on iron nail, is chemically called hydrated ferric oxide. Okay. Next, 8. 8 is corrosion of copper. Like iron rust, copper also rust. Have you seen that electric wire? If you peel the plastic insulation, then inside is a brown colored wire, that is copper. Okay, copper is brown. So take copper. So write your copper a little bit below, which is shiny in the beginning, let us say, not yet rusted. So Cu, and this is brown in color. Not right, but just for explanation sake, it makes it a lot easier. Exposed to air means in the air, the things that react with copper are oxygen will react. Then carbon dioxide, a little bit present in the air, also affects copper. Okay, affects copper. So carbon dioxide, you write. Okay, the water that is present also affects it. So the 3 water vapor. I need to write water, it's so common. So the air which contains oxygen, carbon dioxide, the oxygen, carbon dioxide and water vapor in the air affects copper. Okay, and react over a period of 2-3 months, and then you will see if you put copper brown wire in a dingy place, then this tree will react with the copper over a period of 2-3 months. Greenish color layer will begin to develop. Okay, you can see that even in our copper materials of the door brass and all, green color is there. That means that is the copper rusting. Iron rust, then reddish brown, but copper rust is greenish color develop. That greenish color, that greenish rust is nothing but chemically called basic copper carbonate. And this one we know from worksheet 1 double plus that it is CO3 dot OH2. This basic copper carbonate is always greenish in color. It is the rust of copper. Copper is never green, but when it rusts by reaction with oxygen, carbon dioxide and water vapor, it turns to that color. Okay. So here, remember, this already is balanced. Okay, right side 1, nothing else. So use this side to balance this left side, like you did for iron. We know 2, but here nothing to put 1. Where is this? So 1 Cu plus 1 Cu is 2 Cu on the left side. So here only one place Cu. So copper, put there 2. So left side also 2 Cu. Then next here Cu is copper, C is carbon. These are not same C. Okay, this is copper C and this is carbon C. 1 carbon. This is not carbon. This is copper. 1 carbon here, so should be 1 carbon. So 1 carbon left side already, 1 carbon right side. So balance. Then we have to go to O. 3 plus 2 1s are 2, 5O. So right side there is 5O. We're going to use this because we know it's already balanced, and use this 5O to make the left side 5 also. So 2 plus 2, 4 plus 1, It's also already 5O. Then H is on the one left, so 2 ones are 2H on the right side, 2H. Left side also 2H, so it's already balanced. So we can now read the equation as 2 atoms of copper, because the bag of copper, no number means 1, and 1 means it's an atom. So 2 atoms of copper react with 1 molecule, because the bag more than 1 means there's more than 1 atom, so it's molecule. 2 atoms of copper react with 1 molecule of copper and 1 molecule of carbon dioxide in the air and 1 molecule of water to give us 1 molecule of basic copper carbonate, which is greenish color. So remember, when iron rusts, it turns to brownish red. When copper rusts, the brown color gets covered up by greenish rust, which is basic copper carbonate. 2 more, 9 and 10. So let's go and do that. So here, nine. Let me read for us. Corrosion of silver. So we're studying the corrosion of rusting. So corrosion of silver is silver, let us say shiny. When silver is new, that silver coin, money, it is grayish in color. But when it gets exposed to the atmosphere, there is a minute amount of sulfur in the air. Sulfur is present in the air, okay, a very minute amount. But this minute amount also corrodes silver. Silver doesn't get affected by water, vapor, oxygen, carbon dioxide, but it does get affected by sulfur. But corrosion of silver is very slow. Over a long period of time, you will see that some silver coins, money, develop a black surface, and it's not dirt that has been collected, it's the rust, because it's changing to silver sulfide. Just below the arrow you can write silver sulfide, and silver sulfide is a blackish substance, black in color. So Ag1 plus, we know that, silver ion, sulfide ion is 2 minus, so these 2 will get shifted down here, silver sulfide. So this blackish surface of silver articles is because silver has been corroded or rusted by sulfur, minute amount of sulfur present in the air. So we need to balance now. Ag1, here 2. So we need to make here 2. The bag of Ag2, see here. 1s, here also 1 at the back, so it's balanced now. So we can read as 2 atoms of silver reacts with 1 atom of sulfur to give us 1 molecule of silver sulfide, which is the rust. So when silver corrodes, it turns black. When copper corrodes, it turns greenish. When iron corrodes, it turns to brownish red. We're covering the corrosion area. The last one, that is the 10th, number 10th. Reaction between sodium and oxygen to give sodium oxide. So sodium is a very reactive metal, easily react. Sodium is sodium atom, no Na plus. Sodium reacts with oxygen, so a little bit below the plus you write oxygen. So when you expose a piece of sodium to air, it will immediately explode because it is very reactive and give you a substance called, a new compound called sodium oxide. Let us make the formula. Na 1 plus, sal oxide O2 minus, so 2 will come down here. Right, so the next job is to balance it. So here, let's start with O is easier, I think. 2 on the left side, only 1, so we cannot balance from back, so right in front, 2 ones are 2O. Right, the moment you do that, these 2 2s are on the right side, it becomes 4 sodium atoms. Here also, therefore, we need to put 4 to make it 4 sodium atoms, so it's now balanced. 4 sodium atoms reacts with 1 molecule of oxygen to give us 2 molecules of sodium oxide. So this concludes the portion for Test-1C. You practice like this, and once you think you have grasped the idea properly, then you can go and give the test, which is you're going to write without looking. Okay.